Alright, we're going to look at some basic function graphs that every algebra student should know. Okay, I've laid out several functions here that we'll try to understand why the graphs look the way they do. Let's begin with y equals x. If x is 0, then y has to equal 0, so you get the origin as a point. If x is 1, then y also has to be 1, so you get this point. If x is 2, then y is 2, so you get a point like this. 3, 3, negative 1, negative 1, negative 2, etc. And so you can see that this is a straight line through the origin that is basically at a 45-degree angle is what it is through the origin. If you look at y equals x squared, if x is 0, then y is 0 squared. So if x is 0, y is 0. If x is 1, y is 1 squared, which is 1. If x is 2, y is 2 squared, which is 4, so that jumps way up here. And if x is 3, y is 9, which is way up here. Similarly, if x is negative 1, y is negative 1 squared, which is positive 1. Negative 2 squared is positive 4. And you can sort of see the symmetry that you get here. And you end up with a parabola. Now there's nothing terribly special about x squared. In fact, this can be y equals x to any even power. X to the 12th looks just like this, except it's narrower, it grows faster, so it would look more like that probably. But regardless, it has the same shape. Y equals x cubed is very similar to x to the even power on the right side. It does something like this, because if x is 1, y is 1 cubed, which is 1. If x is 2, y is 2 cubed, which is 8, which is way up here. 3 cubed is 27, so you can see it grows pretty fast. Now if x is negative 1 cubed is negative 1. So it's down here, not up here as before. You don't get a positive number because it's to an odd power. Negative 2 cubed is negative 8 down here. And so the left side of this graph looks like this. It's basically the reflection of this side of the even-powered graph. Okay? And again, there's nothing special about the 3 exponent. Y equals x to any odd power looks like this. Now, that's almost true. Our first graph was y equals x to the first, so this is only true if the odd number is greater than 1. So if x is raised to an odd power that's greater than 1, then it looks like this. Absolute value of x. If x is 0, the absolute value of 0 is the y, so you get 0, 0. If x is 1, y is the absolute value of 1. If x is 2, y is the absolute value of 2, etc. And you can see that the right side of this graph looks just like the graph of y equals x, because when x is positive, y does equal x. The difference is when x is negative. So if x is negative, if x is negative 1, y is the absolute value of negative 1, which is positive 1. So instead of going down like this point did, it goes up. And so you end up with this side of the graph looking like this. So you end up with this V shape for absolute value of x. This is one of my favorites for some reason. The square root of x. Well, if x is 0, y is the square root of 0, which of course is 0. If x is 1, y is the square root of 1, which is 1. If x is 4, y is the square root of 4, which is 2, so that's over here. If x is 9, y is 3. So you end up with a graph that looks like this. And notice that you can't have any negative x values because you can't take the square root of a negative and end up with a real number. So the graph looks like this. And again, there's nothing special about a square root. In fact, this could be any even root. The 12th root of x has the same shape, except it's flatter. Okay? The cube root of x, similarly, if x is 0, the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3, and so you can see it gradually gets bigger and bigger, higher and higher as you go to the right. But now since this is a cube root, you can do negative x values. So the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. And so the left side of this graph looks something like this. And again, there's nothing special about, not terribly special anyway, about the 3. So this could work for any odd root greater than 1 again, because the first root of x is simply x and looks like this. So those are your basic functions.